Alright, in 12.3, we're going to talk about simplifying our rational expressions. And this is where it really starts to get fun and why we needed to know factoring before we could do any of this stuff. So a rational expression is an algebraic expression, that means no equal sign, whose numerator and denominator are both polynomials. The value of the polynomial expression in the denominator cannot be 0, just like before. This means that rational expressions may have some excluded values. So some of them are going to be as straightforward as the ones yesterday when we were graphing. Others, as you can see in 1b and 1c, are a little more difficult to find. So 1a, remember how to find excluded values. We don't want this stuff to be 0, so we can set it equal to 0 and solve. Subtract 5. We end up with this. T can never be negative 5. This is an excluded value. The next one, though, I can't just set this stuff equal to 0 and solve. Because I have b's in b squared and 5b. So in order to get b by itself, what I need to do is factor this, and then remember the zero product property. If two things multiply together and they equal 0, that means we can set them both equal to 0. So how would I factor b squared plus 12b? Well, there's GCF. They both have a b, so I'm going to take that out. And then I'm left with b plus 5. Can't do anything else with it, so this is all done factoring, and now I get to split it up into two things. B equals 0, and then b plus 5 equals 0. So this one's already solved. This is one of my excluded values. I can't plug in 0 for b. And you can go back up here and see why that wouldn't work. We'd end up with 0 in the denominator. But then the other thing that it can't be is negative 5. If I solve that one for negative 5, or for b, I end up with negative 5. If I plug in negative 5 into that equation up here, I will get 0, which isn't allowed. So this one has two excluded values. Two values that will not allow it to work. So how about 1c? Take this denominator, and we want to figure out what values will make k equal to 0. And this is like the extra credit on the last test, that some people knew what they were doing and other people didn't. But I want to factor this. Set them both equal to 0, and that will tell me what k cannot be. So if I factor this, I want two numbers that add to make 7 and multiply to make 12. And I picked an easy one for us. 3 and 4, and they equal 0. So now we can set both of these things. K plus 3 equal to 0, and k plus 4 equal to 0, because of the zero product property. And then when we solve, we see that we have two excluded values here, negative 3 and negative 4. If you plug either of those into your equation down here, you will end up with 0 in the denominator, which can't happen. So simplifying them. A rational expression in its simplest form is when the numerator and the denominator have no common factors except for 1. Kind of like fractions. If I give you a fraction like 6/8, that's not in its simplest form. So what we would do is say, well, what's a number that goes into both of them? And 2 goes into 6 3 times, 2 goes into 8 4 times. Then we could cross those off, because 2 divided by 2 is 1, so we'd get this. 3/4, which is now in its simplest form. 3 and 4 don't have anything in common besides 1. So we're going to do the same thing with all these polynomials. Remember that to simplify fractions, you can divide out common factors that appear in both the numerator and the denominator. So to simplify each of these, we need to find excluded values first. You always do that with the original equation, and then see what we can cross off or simplify. So the very first one, 2a. We don't want our denominator to ever be 0. So if I take this part, 15 times m can't be 0. So that means our excluded value is m equals 0. So now let's simplify. I have numbers and I have m's. So we've already kind of done something more like this, where it's a monomial. But 5 and 15 can be simplified to 1/3. And then m squared over m, you can think back to the exponent rules and you could subtract those. Or you could think you got 2 m's on top, 1 m on bottom. So one of them cancels out and we're just left with 1 m on the top. So this is the simplified form along with our excluded value. And in the simplified form, the excluded value doesn't come into play. But remember, if I was plugging that value in, I would end up with 5 times 0 squared divided by 15 times 0, which would give me 0 in the denominator. So make sure you find your excluded value from the original equation and then simplify it as much as possible. So the next one, 2b, find our excluded value first. So I want to make the denominator equal to 0 and then solve. So if I have something squared like this, I can take the square root. That's the opposite of squaring. So in order to do that, I want to subtract 2 from both sides. And when I go to take the square root, we're trying to take the square root of a negative number, and that can't happen. So because of that, this means that there are no excluded values. Any number will work for this one. And that's because you're going to type it into squaring it. So positive, negative, or 0, you're going to get a number out, and then you're going to add 2 to it. So there's nothing you can plug in there that will give you 0 in the denominator. So now that we have that part done, let's do some simplifying. So the top part of this has a GCF that I can pull out. They both have a 6 in common, and then they both have at least one p. When I take that out, I'm left with p squared plus 2. And in the denominator, I can't simplify p squared plus 2. It's not a difference of squares, and there's no GCF, so I just have p squared plus 2. And the awesome thing about this simplifying stuff is it's kind of like a puzzle. You should, for the most part, always have something to cross off. Chances are, if you don't, then it's a really easy problem, or you didn't factor something completely. So we can see that on the top and the bottom here, we both have a p squared plus 2. So because everybody's multiplying, I can cross those guys off. And all I'm left with is 6p. And that's the simplified form of that rational expression. So 2c, first thing we got to do is find our excluded values. So you take the denominator, set it equal to 0, and we get that n can't be 2. That's our excluded value. And then we want to simplify. So the top part, we can't factor it at all. It's just a monomial. And then in the denominator, we have a binomial that we can't factor. It's not a difference of squares. There's no GCF. But n minus 2 is one thing. So even though they both have an n in the top and the bottom, you can only cross things off if it's multiplication by the exact same thing. So think back to this problem right here. These two had the same things, and it was being multiplied by 6p here, and then multiplied by a 1 there. Because it's multiplication, and the p squared plus 2 was exactly the same on the top and the bottom, I could cross them off. Here, it's n minus 2, and then just a plain old n. So because of that, even though they both have the same letter in there, I cannot cross them off. So we're done. Can't be simplified. This is the simplest form. So of course they get a little harder. We have some trinomials now, and this goes back to factoring. This is why we decided to do Chapter 12 before we did Chapter 9. So factor both parts. Let's see what we can get. So on the top, r plus 2. Can't simplify it at all, so let's just leave it. But remember that that's one thing. You have r plus 2. And then in the denominator, I want to factor r squared plus 7r plus 10. So I want two numbers that add to make 7, and those same two numbers have to multiply to make 10. Well, I have 2 and 5. And now because everything is multiplied together and both the top and the bottom have an r plus 2, you can cross all of that off. So on the top, we're not left with 0, we're left with 1, because this could be thought of as r plus 2 times 1. So we get 1 over r plus 5. That's as simple as it gets. And because it didn't ask us to find the excluded values, we don't need to worry about that for this problem. If it does ask you to find them, make sure you include them. Try 3b on your own right now, and then see if your answer matches mine. So I factored both the top and the bottom, and I ended up with b plus 5 times b minus 5 divided by b plus 5 times b plus 5, or b plus 5 squared. But it makes a little more sense to write it out now, because then we can see that both of these cross off. So we're left with a b minus 5 on the top divided by b plus 5. And remember, we cannot just cross off those b's and then simplify negative 5 plus 5, because this is one term right here, b minus 5 and then b plus 5. So we can't just cross them off. So now the next ones that we want to try have some opposite binomials in them. So let's do the first one together, and then you can do the other two on your own. So the very first one, 3x minus 12. See what they have in common. They both have a 3, so let's factor that out. I'm left with x minus 4. And then on the bottom, this is a difference of squares, but it's a backwards difference of squares. So you can do a couple things with this. You could write it out as 4 minus x times 4 plus x, or you could change it in the beginning. I'm going to leave it like this, and then see what I can get to cross off. As of right now, nothing's exactly the same, but some things are pretty darn close. These two, the one on the top and this one right here, are pretty close. You have one negative and one positive number. So we need to think back to that opposite thing that we did, where I can turn this one down here into negative 1 times x minus 4. So let's change the whole equation into that. The top's going to stay exactly the same, 3 times x minus 4, divided by, now I have negative 1 times x minus 4 times 4 plus x. And now we can see here that these two terms here cross each other off. And then we want to simplify our numbers. So 3 divided by negative 1 will give me negative 3 on the top. And then there's nothing else there. But on the bottom, I have this 4 plus x. Or we could write it as x plus 4. Either way. Try 4b and 4c on your own, and we'll check those in class tomorrow. Have a good night.